Well, probably open it. So today we're going to multiply vectors. We haven't done multiplying vectors yet. We multiplied by a scalar. We haven't actually multiplied vectors yet. In order to multiply vectors, you have to remember the formula for it. So the formula is at the top. It's called the dot product. And when you see two vectors and you're asked to multiply them together, it's usually going to be vector u dot vector v. So we're using the dot product. The dot product is, when I think of it, I kind of think about it related to matrices, or when you multiply matrices, you do like row and column, you like multiply individual pieces and put them all together. It's kind of the same way, only not as complicated because there's only two numbers and two numbers, so it's kind of the same method, but it's simplified. So here we're going to multiply the two x's together. We're going to multiply the two y's together, and then we add those together afterwards. And that's the dot product. That's how you multiply vectors. I would not give you this formula. So you'll do it a bunch of times and learn it. There's some properties of this dot product that explain things like if you multiply u times v, you can also multiply v times u and get the same answer. Things like that. The one important one that we're going to look at on the next page is this one here, but I'll rewrite it again on the next page. That says if you're multiplying a vector multiplied by itself, you get the same answer as if you took the magnitude and squared it. So we'll do that on the next page. Let's do some examples. Find each dot product. So we're going to multiply our x's together, 4 times 2. Add that to multiply our y's together, 5 times 3. 8 plus 15, 23. This one here, if I'm going to multiply my x's together, plus multiply my y's together, I get 0. Oh no. And then the third one, 0 times 4 plus 3 times -12. In the book, it's going to ask you if your answer is a scalar or a vector. It's going to ask you if your answer is a scalar or a vector.
I didn't do that.
No. I don't know what I did there. I saw it wrong in my mind. You know what's funny? This is
like A, okay, B, okay, C.
That's what's funny is the third time I do this today. The third time I do this today. I did not make that mistake earlier.
Maybe you just look it up before.
I guess, but then the negative and I don't know. Whatever. That's the last mistake I made this year. My problem is like my brain is always on the next step and thinking about what the next thing is. That sometimes I make mistakes like that because my brain's ahead. The problem is my brain is too fast. Okay. So the question the book's going to ask, it doesn't say it here, so I want to make sure we go over it, is this a scalar or a vector? So if it's a vector, it's going to be in chevrons with two numbers and a comma in between. Is this a scalar or a vector? If it's a scalar, it's not a vector. This one would be a scalar. This one would be a scalar.
Since they're all scalar.
It's okay. They're not vectors.
Okay.
Gosh, you gotta work that out before you're going to college, buddy.
Look, I'll be a freshman.
Oh, will you?
Yeah.
When you're in that big hall of 100 people and you can't
I don't
even...
plan to go to a big school because I work best with smaller classrooms. So like, big lecture halls, I can have
Okay. That's good. You know what you got, so. Alright, so now we're going to do vector u multiplied by vector v, and then take that quantity multiplied with vector w. So I'll do what's inside the parentheses first, that's dot product. So do -1 times 2, -2, plus -12, that is -14. We're going to take that and we're going to multiply it by vector w. So this here is a scalar. So multiply a scalar times a vector, we don't use dot product. We use what we did in the last assignment. We take -14 and multiply by the x and the y. We get -14, positive 28. So is that answer a scalar or a vector? That would be a vector. Let's see. So the next one, we're doing u multiplied by 2v. When you multiply u times 2v, we're doing all multiplications, so it doesn't matter the order in which you multiply. So I choose to multiply 2v first, and then take that times u. So 2v would be 4, -4, -8. And then we'll do the dot product. -4 plus -24, which is -28, which is a scalar.
Could you refresh my memory on like the two scalar and vector?
Yeah, vectors and scalars. The scalars just another one. The other one.
Okay, I'd rather understand it now than this one later.
That's all right. I don't mind repeating. What I do mind is you never asking and then following up. That's what I do mind. Okay, the dot product of u with itself is 5. What's the magnitude of u? So I told you we'd be using this one on the back. I'll just recopy it so you don't have to flip. But the formula says something like u times u equals magnitude of u squared. So this says the dot product of u with itself equals 5. And it says, what is the magnitude of u? Well, if I want to find the magnitude, this formula just happens to equal the magnitude of u squared. So using this part right here, how can I find just the magnitude of u? Square root both sides. And then we'll have that the magnitude of u is equal to square root of 5. Done. Okay, so then the next question says use the dot product to find the magnitude of u, and then they give us u is 7, -24. So we'll use u times u equals magnitude u squared. So we can find the magnitude by what we did last week. This is asking me to use the dot product, so I'm going to use this instead. So I'm going to take 7, -24, and multiply it by 7, -24. So 7 times 7, that's 49, plus 24 times 24 is 576. That's going to equal magnitude of u squared. So 625 is equal to magnitude of u squared. So how do I find the magnitude? Square root both sides. And we get the magnitude of u equals 25. So if you look carefully, that should, those steps, even though I did it using the dot product, should look exactly the same as us doing the magnitude using the distance formula. You just square the 7, square the -24, add them together, and square root the answer. All right, the next section is the angle between two vectors, and you have a picture at the bottom that is showing what I'm talking about, the angle that is between two vectors. And to find this angle between two vectors, there's a formula. When you look at this formula, this would be a formula that I would give you, okay? you look at the formula on top, it's the magnitude, not the magnitude, the dot product of u and v. On the bottom is the magnitude of u multiplied the magnitude of v. That equals the cosine of theta. So I would give you this formula. I'm not going to show you how to use it. I will give it to you. So you have to know how to use it. So you look at this and you say, find the angle between u and v. We're going to do cosine theta equals, and then we're going to do the dot product of u times v. We'll have, I'm just going to write this in here for now. And that's going to be over the magnitude of u, which is going to be my Pythagorean theorem, multiplied by the magnitude of v. Pythagorean theorem. So on top, I'll do my dot product. I'll get 12 plus 15. On the bottom, I'm going to simplify those. I'm going to get 5 and radical 34. Simplified a little bit further, we'll get 27 over 5 radical 34. And you guys all yell at me and say, wait, we can't have a radical in the denominator. Okay. So we'll say, fine, I'll rationalize it. And I get 27 radical 34 over, and I multiply that stuff together, 170. What am I trying to find when I'm done? The angle. I'm trying to find theta. Right now it is cosine theta. How do I get rid of cosine so it just says theta here? Cosine inverse. So to both sides you do cosine inverse. So in your calculator you're typing in cosine, unless you have that one memorized. I don't think we have that one memorized, do we? Is that on the unit circle? I didn't think so. No, it's not. I'm just making jokes here. So if you have that one memorized, and they will give you some that you know, like you might have to do the inverse cosine of 30 degrees, and you should know that one. But you wouldn't know that one. I didn't mean 30 degrees, what I mean. Inverse cosine of 1/2, or inverse cosine of radical 3/2, like where you know that thing. You guys know what I'm saying. Okay. So this would be 22.166 when you type it in your calculator, and that is degrees that we just found. That is degrees. What happens if you don't put a degree symbol? Well, probably is rating if we're talking angles. If you don't have units, I don't know what you mean at all. And like on that quiz, I took off on people just because I degrees on because we're dealing with angles, so you have to have the correct one. Okay, the very last question. This is a dot product formula, and is an alternative form of finding the dot product. And this would be another formula that I would give you. So you wouldn't have to memorize this one. Just use it. So it says, oh my gosh. I'm just going to scroll down. You guys have it. It says, if we have the magnitude of u and the magnitude of v, and we know what the angle is, we can find the dot product by using that formula. So we do 50 times 30 times cosine of 3 pi over 4. And then you say to yourself, 3 pi over 4, that sounds like something I should have memorized. So you think 3 pi over 4 is in second quadrant, it's a pi over 4 or 45-degree reference angle. What's the cosine there? Is it positive or negative? Negative radical 2 over 2. We'll multiply those together. You'll cancel the 2 with the 1500. You'll get negative 750 radical 2 as your dot product using the other formula. So that's it. If you struggle on this assignment, there's something you don't understand, you can come see me or ask me questions tomorrow in class like you did today. Because it should be easy. Use your decks. Can I go? Put up the assignment and get out of the way because I don't want to be in your pictures. You guys have some time to work on it. grab a look. There's some around the room already. You want to grab some that are already out. I put it on Canvas. It's on Canvas. And then as soon as I upload these notes, those notes will be on Canvas. I'm going to stop the video.